Let's pray. Our gracious and heavenly Father, Lord, we thank you again for today that we can learn words. We want to pray that you in our midst learn and understand how to be taught. In Jesus' name we pray. Amen.
Amen. So this one is part 1. So part 1, it is the one which does not include graphs. It deals with standard deviation. Standard deviation. It has nothing to do with graphs. It carries 6 marks. It carries 6 marks. Okay? So that is the part that we want to look at. But statistics, the definition is very straightforward. It is a branch of mathematics that deals with data collection, data collection and data interpretation. So that's what statistics deals with. It deals with data collection and data interpretation. So you will be given questions where they collect data. They've collected data for you. Yeah, and most of the Zambian syllabus D questions deals with real situations problems. Real situations. Maybe they will present to say 90 farmers. Maybe they will say a group of 90 farmers were asked which crops they planted in the year 2023 or in the year 2022, and below were their responses. So maybe or we can say a group of 90 farmers were asked how many bags of maize were produced in the year 2022. And then now, maybe farmer number 1 responds to say, I produced 20 bags. Farmer number 2 says, I had produced again 20 bags. I had produced 50 bags. Just like that, 100 bags, and so on and so forth. Okay? And then you have all the information. So statistics will be dealing with the real-time situations. So here, using the example of a farmer, we've got 2 things. Number 1, number of farmers. So the number of farmers or the number of people under statistics, we call it frequency. Okay? So any number of people, whatever you're dealing with, those people you're dealing, because you'll be dealing with people, those people you're dealing with, it's frequency. And it is labeled with delta Y. Okay? And now, the products, the things that you are involved, what you are questioning them. In this case, it's bags of maize, right? In under
Mm-hmm.
statistics, that's X. It's for the variable. It's not people, but it's a variable. It's a product of what you want. So in the presentation, we use X. Okay. So even when plotting, when we reach the time of plotting, we'll be able to say, okay, X here, it will be the number of bags. And then Y here, it will be the number of people. To say those who had produced 20, they were so much. Okay. That is now Kuntanshi, not for today. Now that you've collected the 90 farmers, you've collected data and what they've produced. That data that you've collected can be in two ways. Okay, it can either be grouped data or ungrouped data. What did I say? The data that you've collected can either be grouped or it can be ungrouped. Are you there?
Mm-hmm.
Yes. So when we say grouped data, it looks like this. Um, Let me start with ungrouped. Even from the word ungrouped, like you have not grouped the data into proper standardized information. Like it's random. They were just giving you random information to say, okay, two produced this, another produced 20, there's a 50, there's a 60, there's a 80, there's a 100 bags. That's random. That's ungrouped. Okay? But mostly for grouped, you arrange it very nicely into frequencies, into ranges like this. For instance, marker grouping, we put it in a table as grouped. Here on top, you put number of bags of maize. Here you put frequency. Frequency, I mentioned, it's the number of farmers. Number of farmers at Nanendesh. And then you say, you observed that some people produced from 0 to 10 bags. Those who produced 0 to 10 bags of maize, there were 5 people or 5 farmers. That is grouping. You are grouping the information. You say, okay, those who produce from 10 to 20 bags, I saw 20 of them. You keep going. That's grouped. That's why Monica grouped information that like nicely like a table is given, number of maize, number of farmers, and then there's a range. There's a normally range because we are grouping them into ranges from this to that, from this to that. So that is grouped information. So statistics, yenda quite in a story, madam. It goes like a, like a story information. Um, Apple yeah, then put it here then. So now I said statistics is a collection of data and interpretation of data, isn't it? So Kulava, this is the information which has been collected. Okay. So by profession myself, I'm a statistician. This was like the main major course that I did or I specialized in. So twarishiba how to collect data and how to interpret data, especially kuma census department. Now that we've collected this data, what do we do with it? We need to interpret. So when now this is now we're looking at data interpretation. Data interpretation. So interpretation helps you to have a real picture of what was happening. There are many ways in which you can interpret data. Quite over to about mode. It can help you to interpret the data. Okay? Mode is the you've got it back a book again. Mode is the most frequent data or the most frequent information. In Nyanja we can say yamene ekitapia kambiri namba dear mode. Maybe you discover that 20 bags of maize was produced because a lot of farmers said they produced 20 bags. So meaning your mode is 20. You have interpreted data. So the word mode will just help a statistician or somebody to know that, oh, so a lot of farmers in this area they like producing 20 bags. They don't go beyond. And if you know that 20 bags, maybe you as a statistician, it will help you. Why do they produce always 20 bags? Or why do they produce a lot of 20 bags? Maybe you now start analyzing other ideas to say maybe they don't have enough fertilizer, maybe the farming areas are not good for farming, or maybe the land is too small. Are you getting the idea of statistics? So that's how we interpret data. So more to help you to say a lot they do this. Okay? Yeah, normally I like giving examples of prostitution in Kawata when I'm teaching a lot of learners to say if we want to end the prostitution or if you want to reduce prostitution, we need to collect data. We find out what are the ages of girls who are involved in this. So when we collect, trust me, one of the ages there will be a mode there. There will be one which will appear a lot, and it will help us to discover why is 18 years more famous than any other years. You get the idea, huh? So that's how you can interpret data using mode. What about that median? Median, you can use it to know who is on the middle. Adi pakati pakati, that's median, the middle score. Okay? Because the word median, middle number. Middle score, yes. Middle value, middle data. But many badi pakati, who are the middle age. The farmers who are in between, they don't produce a lot, they don't produce few. Very pakati pakati. Okay? Another one they bring it is another one they bring it is mean. Okay, mean looks at average. You want to know now once per month you want to know everything as an average. So mean means average, like you add everything and divide by the total number that you have. Okay, that's what it means, like average, getting everything at once, the average of something. Okay, so now apart from mean, we can now use so mean is like now collecting everything all together. Then we can also use what is called that should be number 4. we can use what is called variance to know or to help or to interpret data. So variance looks at the distance. Variance is distance of each score from the center or from the mean. If you want, you can put it that way. Like how far is, if we say I was using at if I go back to the issue of let's say the one for prostitution, we want to reduce the prostitution cases in Kawata. And then we discover that the middle age of those who are actively involved is 18 years. And then we have, let's say, for 25 years. And we have the one for 50 years. So we are looking at, this is a center. So how far is this lady for 50 years from 18 years? You get the idea. That's variance. So variance looks at the distance of its score from the center that you had discovered. So it helps us to know that helping this lady for 50 years will be far difficult because she's been there for years and years. So to convince her, it will be very difficult. So let's look at anyone who is near this age, maybe for 25 or somebody for 19 years. Those will be very easy to convince because maybe that's when they were introduced to this system. I don't know if you are getting it. It's a very good example. So that's what variance. Variance is how far is each number from the center. Then lastly now, it's standard deviation now, SD. SD, standard deviation. So this one, it is, you guys put your books here if you're done. It is a square root. It is a square root of the variance. The square root of the variance. It's just basically the you squaring the distance of each score from the center. So SD is simply the square root of the variance. V stands for variance. So when you hear standard deviation, it is the square root of the variance. And variance is the distance of each score from the center. So that's what we'll be looking at. And there are formulas. And these formulas, they will give you formulas. They will give you formulas. I want the book to be awesome Lankiza. She knows what to do. Now, I want us to concentrate on the formulas. Among all the formulas that they will give you, I want us to. You're done here. The formula that I want us to concentrate is this one, which looks like this. SD, it's on the, most cases they give grouped data information. Most cases they give grouped data information. Okay? So even on the formulas for statistics, they will write ungrouped data. So I want us to focus on grouped data. Okay? I want us to focus on grouped data information. So for you to find standard deviation, you need to apply two things. There is first of all mean, it is what you start with. You need to know mean, which is mean. They will write for you like that. and they will write for you the symbol for mean. Then they will say this symbol stands for add fx over. So this formula will be given to you. You just have to know the understanding of each of these. This thing stands for sum, summation, just like adding. Okay. F stands for frequency, that you know, I mentioned about it. X stands for the value, the variable, the score. This stands for addition, this stands for frequency. Are you following?
Mm-hmm.
So that formula you will be given, but you can master it. And then the last question, the last one, it is SD. So you go where there is this formula. There are two formulas for standard deviation, the first one and the last one. So I tell people to go for the last one. It's on the right, I'll show you. So it's written like this. So that's a formula for standard deviation. I'm waiting for you, Arinani. I want to begin. And this stands for sum, which is add, that you know, isn't it? This one stands for the frequency. This stands for add or the frequency. Yeah, it's just total frequency. If you want, you can put it total frequency. Then this thing stands for mean, because I had written the symbol for mean in the brackets, and we said mean means average. Okay. Iwe teamushe paper yo mkabini. Actually, throw the whole entire bin in the bin. Now, so basically that is it. But for us to apply these formulas, you need to. There's a table that helps us to do this. The table has 5 slots. It's a table that calculates everything, mean and standard deviation at once. So it goes like this. Start with F. So it has got 5 slots. You just write 5 slots in this table. 5 slots. 1, 2, 3. 1, 2, 3, 4, 5. Then down here there can be as many numbers or lines. Going down, there is no limitation here. But we're just talking about on top here. Here, 1, 2, 3, 4, 5. Just 5 slots. You need to indicate your x here, f of x, x squared, f of x squared. So if you are able to do this, you are home and dry. Okay? If you are able to do this, you are home and dry. Okay? So have you written that table? Those who are getting back the books, what's going on? You've drawn that table, madam? Okay. So now, let's look at a very short example that I mentioned about the number of farmers. Okay. But in this case, let's just have, let's say, 10 farmers so that we don't use a lot of numbers. So they've given you this table. It's containing the number of farmers. So this table is containing the number of farmers. So this table has got farmers here. Sorry, not farmers, but number of maize bags. Maize here, and then you write the number of bags of maize. Then here, number of farmers. Here, number of bags of maize. So let's say we've got 0. Let's say equal to x. Let's say equal to 10, and 10 less or equal to x less or equal to 20, and 20 less or equal to x less or equal to 30. And then here we've got 5 bags. We've got a 2. Got a 2 and a 3 bags. Yeah. So then they ask us to say calculate standard adinani endesa. Calculate standard deviation. Six marks. Okay. Copy that. Have you copied?
No.
So now let us begin. We said for you to do this, you need to draw a table which will have 5 slots. Okay. One, two, three, four, 5. 5 slots. Start with f, x, fx, x squared, and fx squared. You need to have a mathematical calculator here. So if we go back, our f, if you had followed me very closely, I said f is frequency. F is a number of the number of what? The number of people. So always F is actually the bottom table here, which is this guy, F, and then on top here it is always X. I've written in blue. So F is you listing 5 alone, 2 alone, 3 alone. If there were other numbers, we list them downward. So I will write 5 alone here to have its own. I will write 2, and I will write I will write 3 here. You are there? So now, we've indicated, if the other numbers down, what do you indicate? For x. So once the meeting ends, you'll log in for the last part. So for x, you have to go back to your other graph here, your other table. X is the middle part here. Look at this. X is the middle part here. So x is in between 2 numbers. There is 0 and there is 10. So what you do, you add those numbers. 0 plus 10. It gives you 10. Divided by 2. We are dividing because x is on the middle. Otherwise, if x was just one number, we could have just listed that number. Now x is in between. So even here, x is in between 10. So we'll say 10 plus 20 divided by 2, 15. Just like that, the other one, it's in between. As long as it's in between, you add those numbers. 20 plus 30 divided by 2, 25. But if it wasn't in between, if it was just on top, one number, one number, one number, one number, we could have just listed one number, one number, one number, one number without anything. So here I have 5. I have, is it 10? And I have, no, I think I have 15.
10, 15.
15, 25, right? Okay, so I only have 3 numbers, so yeah, my table ends at 3. If you've got 10 numbers, you end on 10, just like that. Then this means multiplication. You are multiplying 5 times 5, 2 times 15, 3 times 25. Trust me, madam, statistics is very easy. Kula konka fe table for there. So 5 times 5, it is 25. Here it's 2 times 15, 30. 3 times 25, that's 75. 3
45.
times 25.
45.
That was 75, madam. 3,
3 times, oh, it's 25.
yes. You are there.
Yes.
And then now, um, you guys don't forget degrees. This part, madam, it's saying x squared. This x is here. You've seen this. You are squaring them. I mean, you're square. Yes, but let's just square 5. 5 is squared, meaning 5 times 5. 25 here. 15 times 15, which is 15 squared, it's 225. 25 squared, which is 25 times 25, it's 625. And then, what are you writing at the name? Are you there, madam? Can you subtract properly? Have order. I mean, simple subtraction if you run in. I'll beat you, huh? 180 minus 72, it will give you 112. Now, Koro. Madam, Alecha 180 minus 72, you are Alessanga 112. This is say 90.
Then this one for fx, you can put just the fx squared.
So you'll be multiplying 5. No. Okay, there is f. F is these numbers. Square, x square, it is these numbers. So you're multiplying them. You are saying 5 times 25. 5 times 25. It will be 125. So,
Not squaring.
you have already squared. Ainan, can you subtract properly? 305 is coming from where? 360 minus 305. 55. Come on, Ainan. Don't kumifunda subtraction. Oh, no. Let's have order. Let us have order. That's me, teacher Mubanga. I'm in class. Can you do the corrections, you? I can't start teaching you subtraction, please. That you won't do. I start teaching you how to count. Arinan, are you sure of what you're doing? I can do that. You want me to start doing that? Eh. Oh, guys, let me just finish shortly with the madam, then we conclude. Are you there, madam?
Mm.
So, yeah, they're fine. Dex, FX,
FX.
FX what? I had X squared, I had FX squared. I had three numbers here. Here I had a 5, I had a 2, I had a 3.
Mm.
Here I had 10, 15, 25. I multiplied these two, 5 times 5. I had 25. I had, is it 30?
30 and 75.
75. X squared, I squared this. So it is, I had
20,
I had 25, I had, is it 225?
225.
And
225 and 625.
then here what did I get? So I have to multiply this, this number and this number. So 5 times 25. So I came to have what? 225?
125.
125. And then I'll do 2 times 225. 2 times 225. That's a 450.
Four.
Then 3 times 625. 3 times 625. That's 1875. You are there? So, when you are done, you do a very simple exercise here. Add, don't add, add, don't add, add, don't add, add, don't add. What are we saying? You add these numbers, skip, add, skip, add. Okay? So now,
Mm-hmm.
let's do the addition of these numbers. Let's add these numbers. Yes. Oh, yes. Very nice. Atu does that.
Hey, Madam Jane, how are you? I was
Uh,
thinking we were going to do
uh,
on the Zoom.
but I've recorded the session, don't worry. How about Bachelor Epshaba, madam? Very nice. It was very followable. Indeed. So, Madam Serena, add these numbers. Add these numbers. We are concluding, but
Madam Jane, it's not very hard to do one. At least it's straightforward. When you watch the video, it's not complicated. Mm.
amen. So I don't have. Yeah, yeah, kind of. Just copy the table. So, Madam Selina, I was saying you add these numbers. When you're done with everything, completing the table, add these numbers. I'm getting 10, but I don't have where to put it. So I'll just put it on the side here, 10. I'll put it on the side, 10. Put here. And then we said you add, skip, isn't it?
Yes.
So let's go to this one. It's add, skip, add. So we're skipping the second one, we're adding the third one. Let's add, me, I don't have space here, but the addition will be 25
One.
plus 30 plus 75. 130. So I'll just write here 130. Let's skip, let's add the last part. 125 plus 450 plus 1875. 2, 450. Those are the numbers that are important. Take note. Those are the numbers that are what? Important. So now, having added this number, having added this or having this, they are the ones that will be helping you to fuse in the formula. Okay? So now, the formula is, we said, whenever you're finding standard deviation, every time the first step is to find mean. Okay? You need to find mean. And how do you find mean? You say this formula they give over the sign. So now look at how we apply the tables. Here you are having fx. So if I go back to my table, where do you have fx?
On the third row.
So you have to just get the number because this symbol stands for addition. It stands for addition. And we've already added it is 130 over. EF. E stands for, okay, it's not E, but just like a Greek symbol for addition. But maybe if you can't Mzambi, if you understand that E standing for addition. But in mathematical terms, it's summation. So when we go back to E, our E is the first one, our F. So they are saying, add all these, what have you gotten? 10. So you indicate 10 here. Then you divide. So your mean is 13. I don't know if you're getting it. Yes, 13 bags of maize. That's what it is representing. 13 bags of what? Of maize. Are you there? If it had crazy numbers, you know what to do. 3 significant figures, isn't it? And then lastly now, we do standard deviation, which is SD is equal to, I said you pick the second formula, which is at the end, which looks like this. Fx squared over EF minus X mean that. Okay. So now, here, madam, we go back to our table. We need to pick where it's saying fx. We pick that number we've added. The table is here. It is this. You've seen that. And what have you found? 2450. You go back here and say 2450. EF, you already know it's 10. We had gotten 10 there. Are you seeing that? Minus E bar, X bar stand for mean. Here, our mean we found 13. So we go back here and add 13 here. We are here. And add 13 here squared. I don't know if you're getting that. So let's divide 10 into this. I'll use the variable here, so this formula now serves no purpose. So where we say SD, I'm almost done, guys. SD is equals to 245 minus 13 squared. 13 times 13, 169. 169 Let me just move this bracket. 169. Then you do the inside.
Tisha Manga.
Yes, me.
Negative WH ndako.
Awe. Negative ya pakati.
13 squared. Just
No. Kai, negative, it will come as a subtraction. And then now we square root. We have to square root here and say SD is equals to square root. It's giving me something like 8.717797.
not 8.8888.
Me, I'm getting 8.717779.
Getting 8.171779.
Yes. Those are crazy numbers. So you leave to 3. So you say SD 1, 2, 3. So 1 will change to 2. So 8.72 bags of maize. So it means you have found the standard deviation. That is the square root of the distance that each maize is from the center, which is 13 bags of maize. So uh, that's it. That is end of part 1, statistics. Now, I can't do part 2 on the phone. It requires a graph. I have to see what each of you is doing and the like. Otherwise, if it was be able to be done. Now, this is where now online comes as a challenge. How do you teach graphical? You have to see. I can do Kutinacha using special graphing, but I just prefer we meet. So watch out for part 2 where we'll meet physically. We need to agree which day on, especially Sunday, that's when I'm available. We can meet. Or Friday evening, we can meet and do this. Or yeah. So basically, that's what we'll do. So take note. Part 2 is graphing. We have to graph the information on a graph on the X or Y plane. That is what is statistics. So in the evening, we just have to look at some exam questions on start. I'll send, you try. In the evening, I check out. Otherwise, in the evening, we have to start linear programming. Now will just do the part which does not include the graph. The only topic that deals with the graphs in that is cubic function. Okay? Yes. So let me send the the questions in the group that you have to try, and you will see that part A is always standard deviation. Part B, it is graphing now, where you have to do it on the graph. So those are the things that needed to be done. So we are done, unless there are questions. So the first one is from 2016. You can write the years in case you have these papers. You are there? Are you writing? So that's the question. Those who are watching this video, calculate the standard deviation. You should do that. Part B requires the graphical part. And then let me send to another one is here. Yeah, another question is here. Then the last two questions just involves one figure. Guys, I'm done here. I'm just sending some work. Battery. So these are questions to try. So these are questions to try. Okay, so 2019. So these are questions to try. 2019, this is the question I'm looking for. Yes, this is the question that I was looking for. Okay, good night, bye bye, good morning, good afternoon to whoever is watching this video.